anisotropy is the very important, okay? That's the main advantage of the plasma etching, okay, compared to the wet etching, okay? Actually, I'll begin with this, the next slide, okay? And in this case, you know the diagram right-hand side, the upper the right-hand side diagram, you see a mask, right? Okay, mask is photoresist, okay, the mask. And then we want to etch the bottom side, okay, features, okay? Ideal case is the generating pattern exactly matches with the mask, okay? And in this diagram, right-hand side, the vertical that etching actually exactly match with the pattern of the mask, right? The line just follow this, right? Yeah, that is the ideal case, right? But the left-hand side, you see this diagram. Now the underneath of this mask is etched out. Okay, what happens is, when you expose this sample in the chemical, okay, at the beginning, chemical is gonna go into this area opening mouth and then etch the surface, right? When the chemical etch it toward the bottom side, and chemical also can etch the side, right? So that is called the isotropic etching. Any direction can be etched, right? So that means as time goes by, the side wall of this, the trench is going to be etched when we apply into the chemical, right? So, but for the case of the dry etching, we don't want to have that side wall etching, okay? Only toward the bottom side, okay? That 100% isotropic etching is our target, okay? That way, we can make a very fine pattern. Otherwise, the chemical etching case, if we want to etch around one micron, same amount of the width is going to be etched, right? When we etch bottom 1 micron, chemical is going to etch for that 1 micron, right? So in that case, will we be able to etch like a 0.5 micron pattern of the bottom side is 1 micron? No, right? Because when we etch out 1 micron, 0.5 micron is fully etched out, right? Then what's going to happen? The mask is going to just fall down, right? Bottom structure is fully gone when we apply the chemical, right? Wet etching, right? So that's why the plasma etching is very important. Anisotropic etching is very important, okay? So right-hand side diagram actually shows that anisotropic, okay? So, but how we can make those type of the anisotropic etching? Even, you know, like I said, the plasma etching is going to apply some of the chlorine or the fluorine gas, right? This chlorine or the fluorine gas can etch anywhere, like the chemical, okay? While we do the dry etching, okay, plasma etching toward the bottom, this chemistry, chlorine or the fluorine is going to both sides of the wall, okay? Eventually etch it, okay, side wall, okay? So what we apply in this plasma etching is inhibitor. Okay, in this diagram, actually the top diagram shows the ion directivity. Bottom diagram shows the inhibitor formation, okay? We utilize these two, okay? So the red atoms is gonna hit the substrate, okay? And continuously etch out the bottom structure, okay? And by the time we control the chemistry inside the chamber, and then build the polymer sidewall. You see here, bottom diagram shows the red lines. Okay, that is the formation of the polymer. Okay, we generate a very thin layer of the polymer. Okay, everywhere. Okay, then what's going to happen is at the bottom side case, ion energy is high enough. The polymer layer can easily generate removed. Okay. Okay, and then we can etch the green these dots. Okay, but the sidewall case, this one actually blocks the chemical addition for the sidewall of the green. Okay, so actually this red one is not going to be removed when the red dots are coming down, right? So this line stays there, okay, and then block the chemistry. So this way, sidewall is not going to be etched while this plasma etching happens, okay? You understand now, right? So keep continuing this reaction process in the chemistry. We can protect the sidewall and then actually etches only the bottom side, okay? That's the main idea of this, the plasma etching, okay? Okay, so now this is one of the example of the anisotropic etching. You see this, the SEM picture, right-hand side, there is a scale bar, okay? This one is scale bar, kind of measure. From here to here is the 20 micron, okay? In this case, the top opening this structure is the less than, this one is 20 micron, then this one is going to be like around 4 to 5 micron, right? And the wall is going to be less than, this one is 2 micron, this one is, yeah, like a 2 micron one, even less, right? We want to keep this wall while we etch it all the way down around the 50 micron, okay? More than 50 micron, here around like 60, 70 micron. We need to etch this much deep, okay? But if we use the chemistry, we never will be able to generate this type of the form, right? So by having this plasma etching, you can etch this 70 micron deep only with the very small opening area. Okay, it's wonderful, right? It's a great technology, right? So without this technology, you cannot use cell phone. Okay, because all your cell phone is using this process, plasma etching process, okay?